Hello everyone, welcome to thlympic. Today we are going to solve 4 new questions from International Math Challenge competition. So let's start. This is our first question from first category related to simplifying fractional expressions. So for this kind of questions, in general, we follow bad math. So the bracket is first, then the others. But when we follow that rule, this question will take a bit longer time. So when we do a careful observation, so these two may cancel each other and these two may cancel each other. So that's why we decide to remove the brackets first. So while removing a bracket with negative sign in front of it, we need to follow this rule. So the rule says if we have a negative sign and when we remove it, the terms inside the bracket, they change their sign to the opposite. So this is positive and this is negative. So after we remove it, it becomes the opposite. The first one becomes negative, second becomes positive. So same idea, if we follow it here, so this is positive, then negative, but when we check it, it becomes negative and positive. This is related to multiplication of signs. And same thing when we apply here, we have positive, positive, negative. So it will be negative, negative, positive. So after we remove the brackets, we see that these two cancel each other and these two cancel each other. What we left is only these two. So now we have addition of fractions, as you know already. So they must be like terms, but the bottoms are different. So for that, we follow this rule for any fraction a over b. If we multiply both sides by the same number, the fraction will remain same. That's why, so we multiply this fraction both sides by 3. So the reason why we multiply by 3 is we want to make these two equal. So right now they are same, means they are like terms. So for the like fractions, we can add or subtract the top numbers. So -3 plus 1 is -2. And still we can simplify this fraction. We will do just opposite of this. Instead of multiplying, we divide both sides by same number. So if we divide both sides by 2, we are going to get -1 over 3. So this is the end of first question. The second question related to finding a pattern and calculating a certain term. So when we check these squares carefully, so in the first one, it is a 3 by 3 square and 1 square in the middle is shaded. So unshaded is 3 times 3 minus 1 times 1. And for the second one, the whole shape is 4 by 4. So it means 4 times 4, the all, minus 2 times 2 will give us the white ones. Same rule we follow here. So 5 times 5 gives the whole, and 3 times 3 gives the shaded ones. When we subtract, we get the white ones. So now, before we check the 10th term, let's try to find a relation. So if we call this first square, second square, third square, if you check carefully, these numbers are always coming same. And so for the 10th term, this will be 10 square. And for the first numbers, it is always 2 more. So if this is 1, it is 2 more 3. If this is 2, 2 more 4. If this is 3, 2 more 5. So it means if you are looking for 10th, it will be 2 more 12 square. So 12 square minus 10 square equals 144. Also, I have seen another beautiful solution. So they do it in this way. So 2, 2, 2, 2, 4 times 2, or 3, 3, 3, 3, 4 times 3. 1 more than this number. So for the 10th number, it will be 11, 11, 11, 11, 11 times 4, 44. So next question from category 3, it's related to area of a parallelogram. So these two sides are given. These are angle bisectors. It means these two angles are equal and these two angles are equal. So for this kind of cases, we can use some letters to show that they are equal and have same size. So if we call this A, this will be A. Likewise, if we call this B, this will be B. So the total is 2A and total is 2B. So for the parallelograms, we know that the sum of these two always 180 degrees. So reason is this 2A equals this 2A because they are corresponding angles since these two are parallel. So it means the whole is 2A plus 2B, which is equal to 180 degrees. Now, if we simplify this, factorize this one, it is 2 times A plus B, which is equal to 180. And if we simplify these two, so A plus B comes 90 degrees. Now, when we look at this triangle carefully, this is A, this is B. So these two together, A plus B, which is 90. It means the remaining one angle is also 90 degrees. So this is a right triangle. So this is important because to find area of this triangle, height times base divided by 2. So from here, we get that the area of this triangle is 5 times 6, 30 divided by 2, 15. So now, if we draw another parallel line, and we see that we have two parallelogram, and each of them divided into two parts with two diagonals. So these two are equal, and these two are equal. So when we call this A, this becomes A. When we call this B, this becomes B. So the whole parallelogram is 2A plus 2B. Now, if we factor out, we can write it again as 2 times A plus B. We already know what's A plus B. So 2 times 15 equals 30 centimeters squared. So the answer is D. For the final question from category 4, it's about the complex numbers. So first, let's remember what's a complex number. So if Z is a complex number, we have a real part and a complex part, and complex part always comes out with I, so the imaginary part. So, and we also have this relation. If you multiply I by itself, the result is -1. So I squared is -1. So the question says, this is a complex number and this is its conjugate. The conjugate means if this is a normal complex number, so when we change the sign of complex part, it becomes conjugate of that complex number. So let's say Z is A plus BI and its conjugate will be A minus BI. Now let's substitute these two into the equation. So we will have this equation. Let's remove the bracket. So 3I, 3A, then AI, then 3BI, and I squared. So we have this line, and same thing, we can remove the bracket. Remember, if there is a negative sign, they will change their sign, the terms inside the bracket. So this will be negative, this will be positive, as we did here. Now let's simplify both sides as the real part and the complex part. So first, I squared will be -1, as we mentioned here. So this will be -B. So this is a real part. This is also a real part. So we can put together 3A minus B. And these two are the complex parts. I is common. So we take I outside and open the bracket, A plus 3B. Let's do the same thing here. This is real. This is real. So -5 minus A is the real part of whole expression. And here there is an I, means 1I, and here BI. So I is common. If you write it here and open the bracket, we will get 1 plus B in bracket. So now the rule is if two complex numbers are equal, the real parts must be equal to each other, complex parts must be equal to each other. So using this idea, we can write two new equations. 3a minus b equals to negative 5 minus a, and a plus 3b equals 1 plus b. Where is it? Yes, here. So now let's simplify these two equations. For this one, let's get a here. And when we simplify 3a plus a, it will be 4a and minus b, and negative 5 is on the other side. Likewise, let's do it here. Take b here. So 3b minus b is 2b. A plus 2b equals 1. Now we have this and this, but to make simple, here we have plus 2b, here we have a negative b. So if we multiply this by 2, we are going to have a negative 2b here. And when we add with this, so the b's will cancel out for solving these simultaneous equations. So I multiply this by 2, it becomes 8a minus 2b and negative 10. So, and we just wrote it here, and we just copied this one more time. Now look at these two equations. If we add side by side, these two will cancel out. And here we will get 9a and negative 9. We are doing addition. So if we divide both sides by 9, a comes as negative 1. So using one of these equations, it can be this one or this one. So right now I use this one. So if we substitute a negative 1 here, negative 1 plus 2b equals 1. So if we move 1 there, it will be 2. So 2b equals 2, b equals 1. So now we got a as negative 1, b as 1. So our complex number will be a plus bi. So negative 1 plus 1i. So the answer will be which one? Yes, C. So thank you very much. That's all for today. See you in next video.